Hello students, welcome to chapter number 13, Limits and Derivative. Students, today I continue our exercise 13.1, question number 16 related, our limits questions. In the 16, limit x tends to 0, cos x by pi minus x. Before operating students any limits, you first check your denominator is 0 or non-zero. So if I put it here 0, definitely my denominator is a non-zero. So I go to simple our working rule. Yes, there are 4 working rule only. Positive, negative, just separated, and multiply and divide also same as. So students, here I working rule apply. Limit x tends to 0, cos x by limit x tends to 0, pi minus x, and mention there by working rule of limits. WR means working rule. So here cos 0, pi minus 0. Cos 0, 1. My answer is only 1 by pi. Question 17. Limit. Yes, 17 questions students, which is the most IMP questions for exam related. So I just tick mark in most IMP parts. Limit x tends to 0. It should be cos 2x minus 1, denominator cos x minus 1. Very easy. Whenever you given cos x minus 1, cos x plus 1, either sin x minus 1, sin x plus 1, you always take simple conjugate part. So students, I start in conjugate parts. Is same as here. Cos 2x minus 1, cos x minus 1. Conjugate for numerator same as denominator. So cos 2x plus 1 downwards. Cos 2x plus 1. Similarly here, cos x plus 1, cos x plus 1. I extra written numerator and denominator. Check, these two you know. A square minus b square. These two you know. A square minus b square. It means you just showing that cos square 2x minus 1 and here cos square x minus 1. Other two data means this and that. Only I just write down the slightly and separately. Now here minus common taking. You converting into 1 minus cos square x, which is sin square x. So limit x tends to 0. Here only I just take the common minus 1 minus cos square 2x minus 1 minus cos square x, and minus minus cancel. Other just limit apply to working rule. Cos x plus 1 by cos 2x plus 1. Now 1 minus cos square x, indirectly sin square x. So limit x tends to 0. Sin square 2x below sin square x. And other limit apply cos 0 plus 1 by cos 0 plus 1. Now students, here just one little turning point both of these sin square 2x have. I just decided in simple to simple calculations. Just both square I will take separately. So limit x tends to 0. Here take separately square. Internal sin 2x by sin x. And here working rule cos 0 1. Cos 0 1. Now students, this formula you know. Sin 2x. 2 sin x cos x. Yes. So indirectly your numerical is happily done here. 2 sin x cos x by sin x, and here 2 by 2, that cancel. This also cancel, and square as it is. So students, your data is covered. 2 square is 4. Here cos square x. So putting your limits. 4 as it is. Here cos square 0, but cos 0 is 1. Your answer is only and only students, just only 4. Now continue question number 18. 18 also IMP. limit x tends to 0 and the given data ax plus x cos x, denominator same as b sin x, ax plus x cos x by b sin x. Students, here just I will do denominator and numerator just divided by x, because I want to use sin x by x, they converting only 1. So here I just write down we divide x not equal to 0 for numerator and denominator. So limit x tends to 0. Here ax upon x, x cos x upon x, b sin x upon x. Students, this x and this x, this only x and x also cancel, and sin x by x, that's my property, it is only 1. Very easily the numerical is done here. Just I operate our working rule separations. So a constant, other limit apply cos x by b separate, limit x tends to 0 sin x by x, and mention here by working rule of limits. Now easily you will decide it your answer. A same, here cos 0, b, but that is 1. You know students, cos 0 is only 1 upon b, that's your answer. Now question number 19. Very easy and very simple. Limit x tends to 0, x into sec x. Students, here sec x I just converting the reciprocal of the cos. So it is a limit x tends to 0, x 1 by cos x. Now apply the working rule. But before applying, you will check first 0 putted. Cos 0 is 1, never 0. It means sure you have to apply working rule. Denominator is not 0. So limit x tends to 0 x, limit cos x, and mention here by working rule of limits. So it is 0 by cos 0, and cos 0 is 1, 0 by 1, answer is only students 0. Continue, question number 20. In the 20, I think same questions given. Yes, but these also IMP questions. Limit x tends to 0, sin ax plus bx upon ax sin bx, but conditions are a plus b non-zero. So very simple. Students, your formula known, sin x by x is 1. And also I will rebalancing your coefficients. So before I operating any, I just divided numerator and denominator by the x. Yes. So we divide here x not equal to 0 in numerator and denominator. So you just getting here one little point, one of the sin ax by x plus here also by x upon that also same upon x. So does this cancel, that cancel, and internally put down your, simply apply the balancing of coefficients. So limit x tends to 0, sin ax by x Just I show here a extra multiply and divided and multiply. That is your formula. Plus constant as it is. Similarly here constant as it is, and it will be show sin bx upon x, but I will write down b multiply and divided. This is also students known our formula, it is only 1, but here coefficient if you ax, you multiply here a, that also a multiply, but it is 0. Same here students, here b multiply, that also b multiply, it is 0. It means this answer is 1 into a plus b, a plus 1 into b. So my answer is a plus b upon a plus b. This both systematically cancel, and that's your answer is 1, because you given a plus b is never to never 0. So it means your solution is simply over here. Next, continue question number 21. In the 21, your data is again coming to IMP question students. Limit x tends to 0, it is cosec x minus cot x. Cosec x minus cot x, just translate into simple form sin and cos. So limit x tends to 0, cosec x is a 1 by sin x, that cos by sin x, and take simple LCM. So limit x tends to 0, it is 1 minus cos x below sin x. Now here students wait, you can't operate the limits because sin 0 is 0, denominator is 0, then not operate limit. So I will go to conjugate. Here conjugate apply. So 1 minus cos x by sin x. My conjugate data is 1 plus cos x, 1 plus cos x, and these two are the property of a minus b, a plus b, a square minus b square. So your answer is limit 1 minus cos square x, that should be same, and here also same, 1 plus cos x. Students, why I taking conjugate? Because it is your parts of sin square by sin, 1 sin cancel, and denominator is now never 0. So your answer is limit x tends to 0, 1 minus cos square x is a sin square x by sin x, that is same. This sin and this sin cancel. Only and only you have to 1 sin x is remaining. Now check, your denominator is a never 0. So I just operate my working rule and easily create my answer. Simple way. So limit x tends to 0 sin x by the limits x tends to 0 1 plus cos x by the working rule of the limits. So here sin 0, 1 plus cos 0, sin 0 0, but cos 0 is a 1, so 0 by 2, my answer is only 0 here. Yes students, here over that. Now 22, which is very most IMP numerical. Question number 22, the most IMP questions. Question is limit x tends to pi by 2 10 to x by x minus pi by 2, and very simple way you will cover to answer. Before starting students, I will check here my limit is 0 given or not given. If you not 0 given, then you translate, convert in the form of 0 only. Yes, their limit not 0 given. So this pi by 2 related, I will suggest not here related, always limit related. Assume that x minus pi by 2 is equal to t. X is a pi by 2 plus t. This x I will show in place of here x. Now limit changing. If x tends to pi by 2, then t tends to x minus pi by 2. So I will just write down pi by 2 minus pi by 2. Definitely my limit is 0. Students, this process is very simple. Always that related you suggestions and you convert the limit 0, because in the formula limit 0 then they operate. Now my continue starting, our question is solutions. Limit t tends to 0 means this limit change. Here 10 2, what is the x? Pi by 2 plus t upon only x minus pi by 2 is a, this x minus pi by 2 is a t. Now to take inside, limit t tends to 0, it is 2 pi by 2 plus 2t upon t. This and that cancel. You have only 10 pi plus 2t upon t. Now students, wait, you are here if you pi given then, and plus means I will convert anti-clockwise. Yes, anti-clockwise means this side going, and all STC wise. Students, pi plus 2t is your which quadrant? Third. And all ST wise third quadrant 10 is positive. So your answer is limit t tends to 0. It is 10 to t by t. Again translate in the sine cos. It should be here positive taking because in third quadrant it is sine to t below, cos to t and t separate. Now these two are, I make the joining. So limit t tends to 0 sine 2t by t and separate the value. Another here 2 extra multiply and 2 divided. And now take a working rule and they get the answer, students. Very easily your answer coming here. Just I separate the working rule. It is sine 2t by 2t. 2 also multiply and another are separate. T tends to 0, 2 by cos 2t. So my answer is, it is 1, 2 by cos 0. Cos 0 is also 1. Finally, you will cover your answer only and only 2. Yes students, here over that this 22 questions. Now 23 questions have. I will go to our new topic. Yes, now new heading is start. Just lightly change here new topics, and the topic is a sandwich rule. Yes, first I show that what is the rule. Rule is a sandwich rule. Simple and easily I will show that definitions. Sandwich rule means nothing. You know that sandwich, upper layer part, lower layer part, upper and lower both are the bread, and middle order is a eating food. Same as here. Students, if limit x tends to a negative function, this minus indicate left hand side limit is equal to limit x tends to a positive fx. This indicate plus right hand side limits. This indicate left hand side limit, right hand side limit, and here f particular a at x is equal to a. So then limit x tends to a fx is exist. One more time repeat. Left hand side limit indicate minus a, right hand side limit indicate plus a, and original function fx putting x equal to a. If you all are same, then limit is exist for x tends to a. And now I will go to start, students. Question number 23. this question related sandwich rule, all 23 to all questions. So if 2x plus 3 times x plus 1, conditions are there, x less than 0, x greater than 0, then find limit x tends to 0 fx and limit x tends to 1 fx. X tends to 0 fx and x tends to 1. Indirectly, students, here two numerical given. It means 3 marks question, 1.5 for this one and 1.5 for that one. So I will simply explain about that, this one. Sandwich rule apply. So if x less than 0, then x tends to 0 negative. And this 0 negative, it means indicate left hand side limit, this less than 0. Your function is 2x plus 3. Fx is 2x plus 3. And the limit x tends to 0 negative fx, which should be 2x plus 3. Put down x is 0. This answer is 3. Same as now I will go to this plus, right hand side limits. If x more than 0, then x tends to 0 positive. Positive indicates, students, only and only it is a right hand side limit. They should indicate only right hand side limit for positive, and minus indicate to left hand side limits. So here fx is a 0 to more, this one. It means I operate that 3 times x plus 1. Limit x tends to 0 positive. My data is 3 times x plus 1. So 3 into 0 plus 1. Check, 3 and 3 answer same? Yes, same. It means left hand side, right hand side are same. Now I go to third. At x is equal to 0. What's the fx? Exactly given here. Less than or equal to. Equal to present means 2x plus 3. Fx is 0. And that is also you apply f0. And finally you will check left side limit, right hand side limits, and exactly 3 all are same. Therefore limit x tends to 0 negative function is equal to 0 positive functions is equal to f0. If you only and only all are equal, then you can say by sandwich rule, limit x tends to 0 fx is 3 is exist. If you anyone are not same, students, sandwich rule by it is not exist for the limits. Up to that your 1.5 marks over, students. Now I start to explaining x tends to 1 related. Yes, so up to that our half numerical is done. Now I will start to second case. So at if x less than 1, x tends to 1 negative. Check which function is 1 less than, this or that. This is a below 0, that is more than 0. More than 0 means below 1. My fx is 3 times x plus 1. So limit x tends to 1 negative functions. It is limit x tends to 1 negative. My function is 3 times x plus 1. Students, you putting only one number, never apply minus 1. Minus only indicate here, students, it is a left hand side limit. Only put it 1, not put it minus 1. 3 into 1 plus 1. 3 into 2. It is the first data coming. Now continue. If x more than 1, x tends to 1 positive. Now which function it should be 1 positive? Again same as 3 into x plus 1. So limit x tends to 1 positive functions. It is similarly applied 3 into x plus 1. Here also students put down only in place of x1. That also 1 put it. This also 1. Plus indicate right hand side limit. 3 into 2. And last case, at x is equal to 1. Again function is moving ahead to in this greater than 0. It means 3 into x plus 1. So your data is f1. 3 into 2, 6. Check. All are same. That's why I just write down there for limit x tends to 1 negative functions is equal to limit x tends to positive functions and is equal to f1 are equal. So by sandwich rule, limit x tends to 1 fx is equal to 6 is the same case is exist. And here students, your question number 15 to both cases, case 1 and case 2 for x tends to 0 related is answer is 3 and x tends to 1 related students answer is 6 and here answer is 3, sorry by mistakes, and here 6 is happily done. Students, here up to that question number 23 I will stop this video and further explanations for in the same chapters I will explain you in the next parts. Bye bye.